In this video, we will learn how to find the angle if we're given the value of the trig function. Now, we're going to do this without using a calculator, but these are going to turn out to be special angles like, pi over 6, pi over 3, pi over 4, or pi over 2. So, let's go. Take note of the fact that x is between 0 and 2 pi. That means it's within one revolution. So, whenever we have a full circle like this, we're going to have two answers. All right, so be ready for two answers. Now, by contrast, sometimes we're told that we are dealing with a single quadrant, like quadrant 1. When we just have one quadrant, you should be looking for one answer. All right, but in the full circle, we're going to have two answers for a question like this. Okay, when you look at this, a reference angle should be popping into your head. The reason why is because I have insisted for many, many videos now that you memorize these three yellow trig functions. And you should jot them down and then also write the white trig values that flow so easily from them. So, looking at this, cosine of what angle is radical 2 over 2? Well, you know what? Maybe I should mention that 1 over radical 2 is the same thing as radical 2 over 2. It's just that the denominator has been rationalized, okay? Look, if I have 1 over radical 2, sometimes we want to rationalize the denominator, which means we don't want a radical in the denominator. So to fix that, we multiply by the radical in the numerator and the denominator. Now we have learned that when you multiply a radical times itself, you just get the number out. And of course, 1 times radical 2 is radical 2. So as you see, 1 over radical 2 is the same thing as radical 2 over 2. So with that in mind, the cosine of what angle is equal to radical 2 over 2, then you should be thinking pi over 4. Okay, now that's the reference angle. That may or may not be the final answer. All right, so reference angle, I'm just going to put ref. Pi over 4 is the reference angle. In order to know what the actual answers are, I like to draw a quick unit circle. And if we have pi over 4 as our reference angle, then draw pi over 4s. Okay, see how the numerator, see how the top semicircle here has 4 parts? Well, this is pi up here, so each of these will be pi over 4, 1/4 pi. So, there are 4 places, all right, 4 reference angles, which will give me some kind of radical 2 over 2. Again, this is the same thing as 1 over radical 2. There are 4 places. 2 of them will give me a positive radical 2 over 2, and 2 of them will give me a negative radical 2 over 2. Now, this is cosine, and cosine on the unit circle is the x value. So, we want the cosine to be positive because we see that the value is positive here. So just like the x values are positive to the right of the y-axis, cosine will be positive on this side. So these are the two angles that will give us positive radical 2 over 2. So what are they? Well, of course, the first one, each one of these is pi over 4. So the first one is simply pi over 4. All right? But this is 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Okay, or sometimes I jump straight to this and I think, well, this would be 8 pi over 4, and then I just go back 1 to 7 pi over 4. Either way, these will be the two answers to number 1. All right, let's take a look at number 2. When you do tangent, you have to remember that tangent is sine over cosine. All right, and tangent x in this problem equals 1. So that means we need sine over cosine to equal 1. Well, again, look at those values that we write down at the beginning of any trig assignment. The way we set it up, we have sine over cosine, sine over cosine, sine over cosine. So the question is, which one of these will give me 1 if I divide? Well, it would be this one, all right? This is the only one where it's the same thing twice. So 1 over radical 2 divided by 1 over radical 2, that would be 1. Okay, so what's the angle that makes that happen? This is a reference angle of pi over 4. So pi over 4 is going to be the reference angle. All right, let's just jot that down and call it ref. All right, so the reference angle is pi over 4. Now, if we want to know what the answers are, all right, it's possible that neither of the answers will be pi over 4. But here's how we find the actual answers. I like to draw a quick unit circle. And again, we're dealing with a reference angle of pi over 4, so I draw pi over 4s. Okay, by splitting the top semicircle into 4 pieces. So now I have pi over 4s. So once again, when we talk about reference angles, they are always measured here against the x-axis. So that leads to these 4 reference angles. All 4 of these will have a tangent of some kind of 1, but 2 of them will be positive and 2 of them will be negative. We want the 2 angles that will give me a positive tangent. Now, keeping in mind, again, that tangent is sine over cosine. It's easy to see that tangent is going to be positive here. Cosine and sine are like x values and y values, cosine, comma, sine. So in the first quadrant, cosine is positive and sine is positive. So tangent is positive divided by positive, sine over cosine. So that's positive. But tangent is also positive in the third quadrant. And in the third quadrant, that's because both cosine and sine are negative. So for tangent will be negative divided by negative, which is a positive. So these are the 2 positions that we want. Of course, the first one is simply pi over 4. But then this would be 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So these are the 2 answers to problem number 2. Let's look at one more example. Sine of some angle is 1/2. All right, and again, there will be actually 2 angles that will give us positive 1/2. And this is one that we memorize. All right, it's right here. Sine of pi over 6 is 1/2. It's right on our little chart. All right, so that means pi over 6 is the reference angle. Now, the reference angle is not always one of the answers. It's very common, but not always. I like to take a look at a unit circle, whether one's provided for me or if I just have to draw a quick one myself. But pi over 6, all right, so I'm going to take this top half, which is pi, and divide that up 6 ways. all right, which is tricky to do with an electronic pen because I don't draw that straight, people. I'm not a born artist. But I will do my best. So these are pi over 6s. You can see I got 3 here, 3 there, that's 6 of them. So there will be 4 places where I will get, where the sign will give me 1/2. And they are the reference angles, all right? The 4 surrounding the x-axis, if you will, above and below the x-axis. So these are the 4 places. 2 of them will give me a positive 1/2, and 2 of them will give me a negative 1/2. I want the 2 that will give me a positive 1/2. Sine on a unit circle is always the y value. So where are the y values positive? Upstairs, all right? Y values are positive above the x-axis. So the sine function will be positive above the x-axis. So since those are the 2 that I want, what are they? This first one is in fact pi over 6, which happened to be the reference angle, but it won't always be. So what's this one? Well, here I could go like this and go 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and that was fast enough. But it's fun to realize that pi would be 6 pi over 6. So I could just go back 1 to 5 pi over 6. Either way, these are the 2 answers to problem number 3. Before I go, let me just mention one more thing about these problems. Sometimes you may be given a completed unit circle like this, all right, with all the special angles shown, all right, and with these coordinates, understand that the x value is cosine and the y value is sine. So if you're given one of these and you're taking a quiz or something, a question like this is almost trivial because we're being asked the sine of what angle is 1/2. Okay, so the sine is a y value. So we can just look for the places where the y value is 1/2. So for example, if I can get my pen turned on, you see 1/2 is right here. Okay, so that's pi over 6. Okay, where else? Now if you look around, well, that's negative 1/2. That's negative 1/2, all right? All right, maybe you can't see where I'm pointing. That's negative 1/2, that's negative 1/2. Oh, there it is, there's another one. Here's positive 1/2 right here. And look, that's 5 pi over 6 right here. So if your teacher is foolish enough to give you the unit circle, it's almost like cheating because you know, you just look and see where it is. It doesn't really take that much thought. But maybe you'll get lucky. Let's see if we could do that with these ones. Looking at problem number 2, if I had that crazy unit circle, all right, tangent is equal to 1. What angle makes that happen? Okay, if the tangent has to be equal to 1, let's see. So the tangents are down here. So I see negative 1, radical 3. Oh, look, there's 1 right there. So that's pi over 4 right there. Okay, what else? That's negative 1. Oh, look, there it is. There's another one. That's 5 pi over 4. So 5 pi over 4 and pi over 4. Okay, see how if we're given a completed unit circle, we can get those answers in like 10 seconds. So who knows, maybe you'll get lucky. And again on this one. Now remembering that radical 2 over 2 is the same thing as 1 over radical 2, where what angle has a cosine of 1 over radical 2? Well, let's see. Better switch colors. I'll do green. Okay, I'm looking for 1 over radical 2. Okay, and cosine is the x value. So I see negative 1 over radical 2. Okay, here here's one. Hold on. Erase some of this jazz. Here's 1 over radical 2, cosine, x value. So that's pi over 4. What else you got? Oh, look, there's another one. Another x value, another cosine. That one is 7 pi over 4. So pi over 4 and 7 pi over 4. All right? So if you have access to a unit circle that's filled out, you're on easy street. That's it for this video, guys. I hope it was helpful. I will see you on the next video.